am Bindusree, working as an assistant professor in the Department of Electronics and Communication Engineering at Institute of Aeronautical Engineering. Today, we'll discuss about the error detection and correcting code and Hamming code and parity codes. So, in the Hamming code, we are having the error detection and correcting code is there. In the error detection and correction code plays an important role in the transmission of data from one source to the another. Normally, we want to transmit the data from the transmitter to receiver. So here we are using the binary data, binary information. So the bits of that binary values either the 0 or 1. For example, I want to transmit the data, any data. So the data will be combination of the zeros and ones only. If for suppose for instead of the 0 we are giving the 1, so the receiver receives the data completely opposite of that transmitting the data. So why? Because so here we are using the only zeros and ones only. So we want to send the data. So even a single bit of the data will be changing, the total data will be the changing. So easily we have to detect that data. If we are transmitting the data, the noise will be occur. So the noises also will be the added in the data. So when it transmit from one system to the another. So which causes errors in the received binary data at other systems. So for that one, so we want to reduce the data or reduce that noise and reduce that errors. So here we are using the error detecting and correcting code. So generally, whenever we want to transmit the data, so not only the binary data, any other data, we want to transmit the data. So some noise will be occurred. But the receiver received the data. So without the noise, then only receiver receive that original data. So we want to reduce that noise. So it is not possible to transmit the original data. Noise will be the occurred. So, but it is possible to get back to the original data. Whenever we want to transmit the data, so the noise will be occurred. But we want to reduce, so we can reduce that noise. So for this purpose, so here we are using the error detecting code. So for example, we are transmitting the data from the transmitter to receiver. So receiver receive the data. So the data will be correct or not. We can check the data. So that error will be correcting. So that is the error correcting code. So in the error detecting code, so whatever the data will be transmitted to the transmitter to the receiver. So the error will be detecting. So if the receiver receive the data, so we can find out that particular error. So that is the error correcting code. So these are the error detecting and correcting codes. So the error detection codes used to detecting the error in the received data bit stream. For detecting the error in the received data bit stream. So these bits are included appended to the original bit stream. So we want to transmit the data. So whatever the data we want to transmit to the transmitter to the receiver. So here the data will be the combinations of the zeros and ones only. So for that purpose, so here we are giving the some hint. So that is the parity bit. So whatever the data we are transmitting, so for that transmitting the original data and we are giving the some parity bit. So again we will transmit that data. So receiver receive that data. So which parity? So depending on that parity, so the receiver receive that data. So he is somewhat some clarity is there. So that transmitting the data some even parity is there. odd parity is there, like that. So what is the parity bit? What is the parity bit? So the parity bits are the two types of the parity bits are there. Even parity is there and odd parity is there. Okay. So what is the parity code? So if you are taking the any bit of the combination, so we are giving the some data. We are giving the some data. So that some data is either we are giving the right side of that data or left side of the data. So we are giving that some value. So that value is the either the 0 or 1. So whatever the data or parity code, whatever it is, so the data will be the combinations of the zeros and ones only. Zeros and ones only. Okay. So for example, we are giving the some data, some 0, 0, 1 is there. So right side or left side we are giving. So right side means that is the LSB bit, least significant bit. In the left side that is the MSB bit, that is the most significant bit. So we are giving the some value. So that is the either the even parity or odd parity. So the transmitter transmit the data and they are giving the some value. So that is the either the even or odd. So receiver receive the data. So receiver have the some clarity. So the transmitter transmitted some even parity of that code or odd parity, like that. Okay, so this is the parity code. So how we can recognize that is the even parity or odd parity? How can we recognize that is the even parity or odd parity? So for example, we are taking the 3-bit binary code. How many combinations are there? So for example, n equal to 3, n equal to 3. So 2 power n equal to 8 combinations are there. 8 combinations are there. So that values are the some 0, 0, 0. So that is the some B2, B1, B0. Okay. So 8 combinations are there. That is the 0, 0, 0, 0, 0, 1, 0, 1, 0. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. So this is the 8 combinations are there. So here we are finding the even parity of the bits. Based on this binary values, so here we can find the even parity. How can we decide that even parity and odd parity of the bits? So we are taking this any number of the data. So depending on the number of ones. Depending on the number of ones. So if that number of ones are the single one is there, so that is not the even value. Okay. So whatever the data we are taken, so in that data we are mentioning that we are concentrating on the number of ones. We are concentrating on the number of ones. So any data we are having the single one is there, so that is not the even. We are having the number of ones are the 2, 4, 6, 8 are there. So that is the even value. So then that even parity is there. So that even parity is the 0 or 1. So here even number of ones present in even parity code. Even parity code contains the data bits and even parity. The value of even parity should be 0. If even number of ones present in the binary code. Otherwise, it should be 1. So, either we are taking that even parity will be the present, that value is the 0. Or if we can take that even parity is the 1. Even parity is the 1. Even parity is present. So, that particular binary value is the 1. Otherwise, it should be 0. So, whatever it is. So, here 0, 0, 0 is there. So here the no ones are there. So that even parity is the 1. So based on this point, so the value of the even parity should be 0. If even number of ones present in the binary code, the value of even parity should be 0. If even number of ones present in the binary code. So whenever in the data, even number of ones is there, So that even parity should be the 0, otherwise it should be the 1. So based on this point, so what is the concept of this even parity? So the number of ones are the even, so that is the 0. So otherwise it should be the 1. So here first we have to observe this one 0 0 0. So here the no ones are there. Here the no ones are there. So this will be the this is not the even or odd. So I will take this one is the. So next one 0 0 1. 0 0 1. So here the number of ones in this data, the number of ones is the single one is there. Single one is there. Single one is there. So this is not the even value. This is not the even value. So that is not the even data. So that will be the 1. That will be the 1. So next data 0 1 0. 0 1 0. So here we are taking the observing this data. The number of ones is the single one is there. So this is not the even. So that even parity is the 1. Next one 0 1 1. 0 1 1. So here the number of ones are the 2. So that is the even. So this even parity is the 0. So next one is 1 0 0. 1 0 0. So here the number of ones is the not the even. So this is the odd value. So it is not the even. So again it should be the 1. So next one 1 0 1. So here the number of ones are the 2. Here the number of ones are the 2. So this is the even value. So it should be the next one 1 1 0. So here also number of ones are the 2. So this is the even value. So that this is the even parity. That will be the 0. So coming to this one. So here the number of ones are the 3. So this is not the even. This is the odd value. So that's what it is the 1. This is the even parity bits. Okay. So based on the number of ones. So we have to give that even parity is the 0 or 1. So the based on that number of ones. So if the number of ones are the even, that will be the 0. If the number of ones are not the even, so that will be the 1. So for example, I want to transmit the data. I want to transmit this data 1 1 1. So for transmit the data, transmitter give that some information. So we are giving that, we are sending the data. So the data, that even parity bit is the 1. Even parity bit is the 1. So receiver receive the data. So this data is not the even. So the receiver have the some clarity. So whatever the data will transmit the data. So the data is not the even parity value. Then he will detect that error and he will check that error. But he is having the some clarity. So whatever the data is there, the data is not the even parity. Okay. So this is the even parity. Okay. So if the other system receives one of these even parity codes, then there is no error in the received data. The bits other than the even parity bit are same as that of the binary code. Even parity code. If receiver receives that even parity code, there is no error in the received data. The bits other than even parity are same as that of the binary code. Next one is the odd parity code. So parity code means, so whatever the data is there, so the data is depending on the number of ones, either that is the even or odd. The value of the odd parity should be 0 if odd number of ones present in the binary code. Otherwise it should be 1. Odd number of ones present in odd parity code. Odd parity code contains the data bits and odd parity bit. Okay. So here also we are taking the number of bits n equal to 2, 3. So 2 power n equal to 2 power 3 equal to 8 combinations are there. So here also we are taking the B2, B1 and B0, 0, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. So here we are checking the odd parity. Odd parity. So here, so if the number of ones, so here we are having the number of ones. So depending on the number of ones. Depending on the number of ones. So here if the number of ones is the, depending on the number of ones, if the data is the odd value, that bit is the odd parity. So then here we are writing the 0. So if the data is satisfy the odd value, so then that is the odd parity bit. So in that odd parity bit we are writing the 0. So 0, 0, 0 is the 1. So next one 0, 0, 1. 0, 0. So here the number of ones. So here the number of ones are the single one is there. So this is the odd parity. So this is the 0. Okay. So next one is 0, 1, 0. 0, 1, 0. So here we are observing this one. So the number of ones. So here single one is there. This is the odd value. So odd parity. That is the 0. Next one 0, 1, 1. 0, 1, 1. So here the number of ones are the even, not the odd. So it is not satisfy the odd parity of the bit. So then it will be the 1. Next one 1, 0, 0 is there. So here the single one is there. In this data, single one is there. So this is satisfy the odd value. So this is the odd parity bit. So it satisfies this condition, that will be the 0. Next one 1, 0, 1. So here the number of ones are the 2. So it is not the odd parity value. This is the not the odd parity. So it not satisfy that condition. The value is the 1. Next one 1, 1, 0. So here the number of ones are the 2. So here the number of ones are the 2. So this is not the odd parity. The value is the 1. Next one 1, 1, 1 is there. So this is the odd parity, odd value. So this is the 0. Satisfy the odd values, odd parity bits, that is the 0. This is the odd parity code. So whatever the data they are sending the data 1, 0, 0 and they are giving the some data, that is the 0. So the transmitter transmit the data 1, 0, 0 and 0 is there. So again they are mentioning in that one. So this is the odd parity. So receiver receive the data. So the data is the odd parity value. So here the receiver having the some clarity. So that is the even parity or odd parity. Okay. So this is the odd parity and even parity of that code. So up to this, so here we are having the error detecting code is there, error correcting code is there. So whatever the data we are sending, so in that we are giving the some parity bits, that is the even parity or odd parity is there. So how can we detect that error? How can we check that error? So here observing this one. So this is the Hamming code. This is the Hamming code. Hamming code is useful for both detecting and correction of that error present in the received data. Hamming code is useful for both detecting and correcting of errors present in the received data. Okay. So the code uses multiple parity bits and we have to place these parity bits in the position of the power of 2. So if we are sending the data, some data is, we have to sending the data, some data. So here we are giving the parity bits also. We want to send that any data. In the data is the combination of the data as well as the parity bits also. So that is the formula of this one. 2 power k greater than or equal to n plus k plus 1. N plus k plus 1. So n equal to number of bits in the binary code. Number of bits in the binary code. So k equal to number of parity bits. So the number of bits in the Hamming code is equal to n plus k. N plus k. So for example, so here we are taking the n equal to 3 is there. N equal to 3. So this means the total data is the 3 bits. The total data is the 3 bits. So whatever the data is there, so it should be satisfy this condition. It should be satisfy this condition. So what is the condition? 2 power k greater than or equal to n plus k. 2 power k greater than or equal to n plus k. So this is the trial and error method. So how many parity bits we are giving? So that is the parity bits. For example, in the first condition, so if k equal to 0, if k equal to 0, so substituting these values in this formula, so 2 power 0 greater than or equal to n is 3 plus 0. 2 power 0 is 1, 1 greater than or equal to 3. Is this satisfy this condition? No. So, if the k value is not the 0. Next condition. So, if k equal to 1. If k equal to 1. So, 2 power 1 greater than or equal to n equal to 3 plus k equal to 1. So, 2 power 1 is 2 greater than or equal to 4. Satisfy this condition? No. So, the k value is not the 1. Next condition. So, if k equal to 2. If k equal to 2. So, 2 power 2 greater than or equal to 3 plus 2. 4 greater than or equal to 3 plus 2 is 5. Satisfy this condition? Again, no. Next one. If k equal to 3. 2 power 3 greater than or equal to 3 plus 3. 3 plus 3. So 2 power 3 is 8 greater than or equal to 6. Satisfy this condition? Yes. So that k value is the 3. So k value, if k value is the 0, does not satisfy that condition. K equal to 1, not satisfied. K equal to 2, also not satisfied. So whenever we are taking the k equal to 3, so 8 greater than or equal to 6. So if n equal to 3, so the number of parity bits also 3. If satisfy this condition, then we have to take that number of parity bits and the data. Okay. So 8 greater than 6 satisfy this condition. So here the number of parity bits are the 3. Number of bits are the 3. 3 plus 3. So here we have to take the total data is the 3 is the number of bits and the parity bits are the 3 plus 1. So the total data is the 7 bits of the data. Okay. N equal to 3. K equal to 3 plus 1. So the total bits is the 7 bits. So in this 7 bits, so which bit is the data bit and which bit is the parity bit? Here we have to mention the 3 parity bits. So total 7 bits. So where we are writing the number of bits and where we have to write the number of parity bits. We'll check that one. Okay. So this is the P1, P2, P3. So what is the P1, P2, P3? So for n equal to 3 is there. So this is the data. So for example, the data is the sum D2, D1, D0 is there. Okay. So here we are taking the parity bits. That is the k equal to 3. So this is the parity bit. So it is the variable is the P. So P1, P2, P3. These 3 are the parity bits. These 3 are the data bits. Where we are giving the data bit and parity bit, we'll discuss after that. So before that one, so how can we are finding the P1 bit and P2 bit and the P3 bit? first we have to check the first parity bit, find the value of the P1. Find the value of the P1. So, based on the number of ones present in bit position, based on the number of ones present in the bit position. So, what is that one? For example, so here we are taking the 7 bits are there. So that 7 bits are the 0, 0, 1, 0, 1, 0. 1, 2, 3, 4, 5, 6, 7 is there. So 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. So here we are finding that P1 data, P1 bit. So first bit of the data. So here the here we are writing the from the 0, 0, 1 to 1, 1, 1 is there. So in this first position of that data is the 1 is there. So we are considering the data bit. Okay. So this is the first one, LSB bit is there. So in this total data bits, in the first bit of that position, we are having the data is the 1. Then we are considering the data. Clear? So here we are taking the first bit of that. Means that LSB bit is the 1. Then we are considering that data bit only. So here we are having the first bit of that position. B1, B2, B3, B4, B5, B6 and B7 is there. So now I want to find the P1. So here we are considering this B1 value. Next LSB bit is 1 is there. So B2 is not having the, in the LSB bit we are not having the 1 is there. So here we are having the 0. So here we are not taking the B2 value. So in this first bit of the position 1 is there. So here we are taking this one, that is the B3. That is the B3. Next one. Next first bit of that position is the 0. So here we are not taking the B4. Next one is the B5. Next one is the B5. The LSB bit is the 1. So here we are taking the B5. Next first bit of that position is the 0. So here we are not considering this one. B6. Next one is the B7. First bit LSB bit is the 1. B7. B1, B3, B5, B7. So here we are finding the first parity bit P1. So based on the LSB bit is the 1, we are considering the data only. So here the P1 is there. So that's what here we are not considering this B1. So P1 and B1 is there. So here we are considering this B3, B5 and B7 only. This is the one procedure. So otherwise, so in this P1 suffix 1 is there. P1 suffix 1 is there. So based on this, so here we are taking this, here we are, difference is the 1. So based on this, B1. So one difference. So we are not taking the B2. Again we are taking the B3. Not taking the B4, B5. Not taking the B6, B7. Either based on the suffix value, so we are taking the B3, B5. So here the difference is the single bit only. Okay. So next one, P2. P2. So here we are finding the parity bit 2. Here we are finding the parity bit 2. So that means next position. So in this, for we are finding the P1. So first bit of that position is the P1. So that is the single bit. We are considering that one. Next bit P2 is there. So concentrating on the next bit. After LSB bit. Concentrating on the next bit. So in the B1 we are having the 0 is there. So we are not concentrating on this B1 value. Next one, we are taking the second bit is the 1. So now taking the B2. Next one, we are taking the B3. Means next second bit is having the 1 is there. B3. Next bit is the 0 is there. So B4 is 0. Not concentrating on this one. Next bit is the 0. not concentrating on this one, B5. Next B6. Next B6. So here the second bit is the 1 is there. So that is the B6. Next bit is the second bit is the 1 is there, B7. Okay. So next observing this second bits. So whenever we are having the 1 is there, we are taking that bit only. B2, B3, B6, B7. This is the one procedure. Otherwise, so here also we are not concentrating on this B2, B3, B6, B7. Whenever we are checking that parity error correcting, then we are taking this B2 also. Okay. So otherwise, so based on this 2. So here the suffix value is 2. So taking the 2 continuous bits B2, B3. Again B4, B5 is the gap. So next one B6, B7. So more than the 7 bits are there. Again we are not taking the B8 and B9, B10 and B11. So here also same. So here the B7 is there. We are not taking the B8, taking the B9 like this. Okay. Next I want to check the P3. P3. So next bit. Concentrating on the MS bit. So here we are taking the number of bits are the 3. So concentrating on the 3. Okay. So next bit. So in the B1 we are not having the 1 is there in the MS bit. So not taking the B1. In the B2 also not taking the 0. B3 also same. Next we have to take the B4. So next bit MS bit is the B5. Next MS bit is the B5. So B5. Next MS bit is the B6. Next MS bit is the B7. B4, B5, B6, B7. Okay. So here we are taking the depending on the number of MSB bits. B4, B5, B6, B7. So otherwise we have to continuously take in these bits 4, 5, 6, P1, P2, P3. So B5, B6, B7 we are taking the B5, B6, B7. Next we are giving the gap B8, B9, B10. So again we are taking the B11, B12, B13 like this. So this way we are taking the we are finding the parity bits. Okay. For this B1, B3, B5, B7, P2, B3, B6, B7, P3, B5, B6, B7. Okay. So this is for the finding the parity bits. So this is the finding the check the bits. Means so receiver receive the data that the data is the correct or not. So we have to check that one. So based on this check bits, find the value of the C1 based on the number of ones present in the bit positions B1, B3, B5, B7. All bit position suffixes in their equivalent binary value 1 in this place of the 2 power 0. Okay. So finding the check bits. So before this one for the error detecting we are taking the P1, P2, P3, P3. So here coming to this check bits. Same as that bits. So now I want to find the C1. So here we are taking the B1, B3, B5, B7. So that place is the 0. 2 power 0. Next we have to find the C2. B2, B3, B6, B7. So that place is the 2 power 1. Next one is C3. So that place is the 2 power 2. So that is the find the value of the check bits. Okay. This is the example. So let us find the Hamming code for binary code D4, D3, D2, D1, 1000. Consider the even parity bits. The number of bits in the given binary code n equal to 4. So here they are giving the n equal to 4. Data is there. So this bit is the even parity bit. Now we have to find the total data. So n equal to 4. So what is the formula of this one? 2 power k greater than or equal to n plus p plus 1. N plus p plus 1. So sorry, k plus 1. So first one k equal to 0 is there. First position k equal to 0. 2 power 0 greater than or equal to. So here the n equal to 4 plus 0. So 2 power 0 is 1 greater than or equal to 4. Not satisfied. Okay. Next one k equal to 1. 2 power 1 greater than or equal to 4 plus 1. 5. So 2 greater than or equal to 5. not satisfied. So next one, k equal to 2, 2 power 2 greater than or equal to n equal to 4, 2. 4 plus 2, 6. 4 greater than or equal to 6, not satisfied. Next, k equal to 3, 2 power 3 greater than or equal to 4 plus 3, 7. 8 greater than or equal to 7. Satisfy this condition. So here the parity bit k equal to 3. So the total bits is the 2 power k 4 plus 3 plus 7 bits is there. Okay. So here we are taking the data is total 7 bits. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. So already we know P1 bit is there, P2 bit is there, D3, P4, D4, D5 and D6. 1, 2, 3, 4, 5. Sorry, D5, D6, D7. So how can we are taking the number of bits for this position? So how can we are writing this position? So first parity bit 2 power 0. So that is the 2 power 0 is the 1. So first bit. Next k equal to 1, 2 power 1. Next bit 2. Next k equal to 2, 2 power 2 is the 4. Next, if the number of bits are the increases, k equal to 3. So 2 power 3 equal to 8. So next parity bit is the P8. So now we are having the 1 0 0 0 is there. So in the first LS bit is the 0. Next LS bit is the 0 0 1. Okay. So first finding the P1 value. So first finding the P1 parity. So first finding the P1 parity. So depending on the number of bits. So 0 0 1, 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0, 1 1 bit 1. So first LS bit we are having the 1 is there. We are taking that bits only. So in this P1 we are not having the any data. So we are not concentrating on this data. So next LS bit is the 1. So that is the D3. Next LS bit is the D5. Next one is the D7. D3, D5 and D7. So in this D3 we are having the 0. In this D5 we are having the 0. D7 we are having the 1. Already in that question they are mentioning the consider the even parity. Even parity. So whenever we are taking the even parity, so if this data is satisfied the even value, so that is the 1. Otherwise, if the data is satisfied the even parity, that is the 0. Otherwise, that is the 1. So here the number of ones are the not satisfied the even value. So here we are taking the data is the 1. So P1 value is the 1. Next, we are taking the P2. That means concentrating on the next one. Next bit 1. So that is the P2. So P2 we are not having the any data. So next concentrating on the D3. In this P4 we are not having the any data. So coming to the D5, the second bit is the 1. Next D6 we are having the 1. D7 is the 1. So P2 is D3, D6 and D7. In D3 0 is there, D6 0 is there, D7 is the 1. So D3 we are having the 0, D6 is 0, 1. So here the number of bits are not the even. So not satisfy the even parity bit condition. So that is the 1. Next one is the P3. Sorry, P4. Next one is the P4. So in this 4, the MSU bit is the 1. So the MSU bit is the 1. So P4 we are not having the any data, not concentrating on the P4. Next one D5, D6 and D7. D5 is the 1, D6 is 1, D7 is the 1. So this is not also the not satisfy this even value, so this is also the 1. If that satisfy that condition, that value is the 0. So the P1 value is the 1, P2 value is the 1, P4 value is the 1. Okay, so the receiver receive the data is 1001 0 1 1. So P1 value 1, in that place P1 we are writing the 1, P2 is 1, P4 is 1. So the total data is the 1001 011. This is the error detecting code. So here we are finding the parity bits. So 1001 011. So 1001 011. So this is the total data. Now I want to check the data, whether the data is receiver receive the data is correct or not. So here I want to change this data 0. P1, P2, D3, P4, D5, D6, D7. This is the even parity of the data. So now I want to check the data C1. So this is the error correcting code. Error correcting code. So in this C1 correcting code, that's what it will be denoted as some C1 is there. So the values are the P1. So here we are concentrating on these bits P1, D3, D5 and D7. P1, D3, D5 and D7. Okay. So in this P1 value we are having the 1 is there. In this D3 0 is there. D5 0 is there. D7 0 is there. Okay. So already in that problem they are mentioning the even parity. So here the number of ones is the not satisfy this even condition. So not satisfied, that means it will be the 1. If satisfied that even parity, then it is denoted as 0. Next one is the C2. Next one is the C2. So next position is taking the P2, D3. So here we are not taking the P4 and D5. Next one D6 and D7. Okay, P2 is 1, D3 is 0, D6 is 0, D7 also 0. So here concentrating on the number of ones, so that here the not satisfy this even value. So again it will be the 1. Next, coming to this next position, C4, next parity bit, next one. So C4, P4, D5, D6 and D7. So in this error correcting code we are taking the parity bits also. So in this P4 1 is there, D5 is 0, D6 is 0, D7 is 0. So here also number of ones is a single one is there, not satisfy that even value. So that is the 1. So the total one is the 111. So the value is the 111. So this is equal to the decimal value is 7. This is equal to the decimal value is 7. So that error correcting. So that error will be occurred in the 7th bit of this position. Okay. So before that one, here only we are changing the data. Here only we are changing the data. So here 1 is there. So here we are changing the data. 1 will be replaced with the zeros. So this error will be correct or not. So how can we are checking? Based on the error correcting code. So this is the 111 is there. So based on this error correcting code, so here we are finding that number of bit position. Number of bit position, that is the 7. That is the 7. Okay. So in the 7th bit we are having the error. This is the error correcting code. Based on the check parities, checking codes. So here we are finding the error correcting code. So in this session, We discussed about the Hamming code, Parity code, error detecting, and error correcting code. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.